realizing that we really got the order of presenters correct here, that you guys have fresh off the computer science lecture. And now that we have all our concepts straight, I want to talk a little bit more what we're trying to do with some of these concepts. So I'll be talking a little bit about the OSDF and the Pelican project that helps provide software for it. This is part 2 of our 3-part lecture series. Frank will come up next and tell you a little bit about all the wonderful things that we're doing with the OSDF and other services. So if I have to try to fit everything about the OSDF into one slide, the text becomes about yay big. So if I then try to trim myself down a little bit and try to introduce it, I say it's a federated platform for delivering data sets. Here we use the word objects from repositories, object stores, to compute in an effective, scalable manner. So this is the different parts that we're trying to achieve here. We're not focusing on saying replicating objects. As Marone said, we're not focusing on managing and understanding your metadata or taking advantage of what's inside your netcdf files, but we're trying to take those objects and get them to compute for some value of compute, right? We might, in this context, talk all about HTC, hence the name of the conference. But we also want to think, I like to think of these also as browsers, as Jupyter, everything that you can kind of broadly call compute. And we want this to work well and, as Marone said, in a distributed system, take care of failures, and then work effectively for users. So the OSDF is not a one-man shop. In fact, it's not even a one project shop. So one thing that maybe you'll get from the end of this talk is that there's actually lots of people that contribute to make this service work. So in order to have that effective data delivery, we need various pieces of hardware that we've largely located within caches around both the nation and internationally. So a lot of that hardware is from the NRP project. There are processes that are running that take in requests and spit out bytes, and somebody needs to monitor, care, feed, keep those things going. So Path project does the operations for it. And this is all kind of falls under the OSU Consortium's fabric of services. So here we're kind of at about 24 caches or so, give or take. I think we're closer to 3 now. This is a bit of an old map and a growing number of origins. Good. So when I mentally think of what the OSDF does, again, for me, it's all about connecting. I think of all these different data repositories out there that have something that means something to scientists, whether it's LIGO data, whether it's climate-related data sets at NCAR, whether it's the subset of science that AWS has decided to host. And what we want to do is be able to provide a platform that no matter what computing that you're sitting on, whether it's the OS pool, whether it's just a standalone Jupyter notebook running on your laptop or NRP, or whether it's at some of the larger computing capacity that the NSF funds, we want to be the ones that effectively deliver. And Frank has been apt to call it Netflix for science. And for whatever reason, I really disliked that term, but it started to grow on me. That it actually is pretty close to what we do. We're not Napster for science. We're not helping you download and make replicas. We really are trying to stream some well-known objects, your movies, for science to your different compute points. So, Frank, I now like Napster for science, or sorry, Netflix for science again. Historically, though, as Marone said, we kind of coined the term in about 2020. we have been a little sloppy about what OSDF is. In fact, we would use the term for just about everything. And over the last year, and actually it's become really accelerated maybe about 9 months ago, we've been trying to take the parts of the OSDF that were things you put in a Git repository, your software pieces, aggregating them together and calling them Pelican. And then if you take a instance of a Pelican data federation that we operate at the global scale, that one big instance is the OSDF. So it's not that Pelican was born anew, September 1st, 2023. Really, it existed, but we've tried to do better about differentiating the bird and the instance. And this should feel really natural for everybody, because of course that's what we do with Condor, right? You have the Condor software. Condor software just released version 23.8.0, and then we take that and create an instance of Condor called the OS pool. So even though we have new branding, a lot of the pieces, the core that's familiar. So for example, OSDF for a long time, the data movement or the object movement, I should say, has been powered by the XRD software suite. And if you peel back the layers on Pelican, you'll find the exact same thing. So operated by path, hardware OSDF is largely from NRP, a couple other projects. Question is, who develops the software? And that's the piece that came together late last year. And this is what the Pelican project is. So this is, I guess I would use the word new here, but I have to get to the fact that we're almost a year old, so I can't be calling myself new anymore. Maybe if you stand next to Condor, we're still new. But it's a project that will run over the next 4 years. And I think of it as having really 3 big pieces. One is to strengthen and advance the OSDF. So re-engineer some of the foundations, do that software separation, make sure it has that solid underpinning. Expand the types of computing where OSDF is impactful. So being that we're HTC24, this whole presentation is going to have a strong HTC slant. But again, we're starting to also think about what if you want to use this from the browser? What if you want to use this from Jupyter? How does this interact with some of the very large HPC systems or leadership facilities that we have? And then finally, expand the science user communities. And in particular, we're working really hand in hand with NCAR. So a lot of this has been how do we deliver NCAR data, yes, to some of the big iron computing projects that they have. But don't you worry, we're also on the side starting to show NCAR how wonderful the OS pool is. So we're growing in the climate community, and hopefully over the next couple of years, we'll have much more to talk there. Slide's a little slow. So the team probably looks familiar. As you can tell, all these pictures are lies. I think they're all at least 5 years old. Of course, the real team are not the people that operate the spreadsheets, but I'll of course acknowledge the technical staff. Again, a lot of these people might look familiar within the community, but one good piece of news is it has allowed to grow the overall folks. So particularly, we have a couple people out there not here, but you guys will probably see Justin, William, Hao Ming. Let's see, have all started within the last year, and Cannon has been here only 3 years, but he's still relatively new. Matt, I'm sorry, you're old now. I did want to spend a couple minutes on how this whole shenanigan works, just in case if you're hopelessly lost and didn't get the ground pieces. I want to talk a little bit about the OSDF itself. I love talking technical details, and I get 20 or 25 minutes to talk technical details tomorrow. So if you feel that you're still left wanting about how all this stuff comes together, there's a great talk tomorrow about it. So again, the most common way that we'll use the OSDF is to deliver objects to jobs running in the OS pool. And right now, there's really three bigger clients. We have a couple other things cooking. There's a plugin and integration with the HTCSS software. There's a standalone CLI option, that has semantics similar to CP. And there's now starting a Python client for folks maybe using the Python data science ecosystem. So this is a FS spec implementation for those of you from Python land. And of course, being HTC24, I'm going to run through the first one. So let's say a EP on the OS pool has just received a new job that it would like to start. The very first thing it does is, of course, it knows I need these pieces of input in order to start the job. So maybe the most common one is I need a container, right? I have a 600 megabyte container that runs this job. Where do I get it from? Within HTCSS, we have this idea of a file transfer plugin. So we have a little piece of code that gets launched. This is for us the plugin or the Python client here. And the very first thing that the client does is starts up and discovers a service that, at least here, I'll label the manager. And I'll tell you, manager, here's an object I want to read. Please give me a service that can deliver it. So it starts up, talks to our manager. Now, within the OSDF, that manager, right now it's sitting in Wisconsin, is connected to a number of different services. Again, those were the kind of 4 dozen, 5 dozen different caches or origins that are located throughout the US here. And the origin or the manager has to make that decision of how am I going to deliver the object to the client? Or if it's happened as the stage out to the end of the job, where am I going to store that object? So right now, a lot of that decision is based on GeoIP. So it's going to pick a cache that's close. You can imagine we're also cooking other things, such as maybe we pick a cache that actually has the object. Maybe we pick a cache that's lightly loaded. But let's say we start with GeoIP and say, okay, cache, we think this is the service that's closest to you. The client will then go talk to that nearby service and say, hey, manager just told me, get this object from you. Well, the object is local. It'll deliver it immediately. Otherwise, if it's not local, the cache itself has to ask the manager, hey, manager, I have a request for this cache or for this object. Please deliver, where can I get this object? And right now, the cache will be told, hey, go talk to this particular origin. And that origin will then convert that request for an object to say, here, I've drawn a POSIX file system. So it opens the file in the file system, delivers the bytes through, and the bytes end up going all the way back to the client. And obviously, the whole point of the system is the observation that this way we have the client can only works with the content distribution layer, and we can take advantage of the fact that there's some amount of reuse and reduce and manage how much load we put on the origin. Or sorry, and really the underlying repository or objects store. So again, the 3 big components besides the client, we have an origin where all the objects live, where all the objects are moved through, the objects live in the object store. We have the cache service that helps deliver and scale the ecosystem. And then we have the manager service that manages the namespace and tries to decide what's the best endpoint for each of our clients to use. And if you can get those 3 things, I guess that's somewhat of a pinkish understood, and realize that the data lives in the object store, not the origin, you're going to pass the quiz at the end of the coffee break. This is not my favorite pointer. So long term, really the vision here that we want to do is I think of the OSDF as a transport bus. I want to plug in as many different object stores as of many different types as I can into this common fabric that then your different clients and users of those objects, instead of having to, say, have the OS pool have one client for this data, one client for this, one client for this, but to have that common layer that the OS pool needs the one Pelican-based client, and then any data that's in the OSDF it can access. So we're 1 year down the line. What do we have to, or about 1 year down the line, what do we have to show for ourselves? We re-architected a lot of the core services. That manager component has basically been rewritten from scratch. And a lot of the advantages now is everything is HTTP based within the system. And we've added a separate registry that we can then associate the list of approved caches, register things, have some security so we know this particular public key is associated with this part of the namespace. These central services have some built-in monitoring. We can do connection brokering. I'll get to that in a second. We can do testing for functionality. And overall, this is something that we've really been able to help provide some of the standardized workloads for. Pelican has really become a standalone piece of software. So when we started separating the two, you literally could not set up a second instance of the OSDF. There was no, this is the production OSDF and this is the test of OSDF. And things were so integrated with such a variety of services. They had things calling directly to OSG topology. There were things that called the WLTG GeoIP service. You couldn't kind of draw a circle and say everything here is the OSDF software stack. So it's not that we stopped using any of these pieces like OSG topology, but we put in an abstraction layer. So we can cleanly say, here is a data federation instance, which now means that we can set up a test instance. It means that we can write unit tests and integration tests. I can tell you every commit we merge, we have dozens of tests that pass versus pre-Pelican, it was kind of like, oh, well, nothing bad seems to happen. Let's ship it out to production. So as I say, it kind of looks more like a software properly engineered project with tests. And we now know our test coverage metrics and things like that. As I say, it's not really a user visible feature to say the software is well tested, but I hope everybody appreciates that. And if you want to look at another metric here, this is the number of commits per week to the main repository. And here's about where we started Pelican. And hopefully you can tell the difference. We had started deploying these new and updated versions of the software out to the OSDF. This has actually been a lot harder than maybe slower than we anticipated, because of course we find every single edge case where we didn't understand how people were using the OSDF and had to go back and add that feature in, add that feature in. We're not going to shut down the OSDF or tell everybody to upgrade their software concurrently. So of course the traditional analogy is changing the engine while the airplane's flying. We have a Pelican, and this is about the best as I could do with AI for changing the engine of the Pelican while it's flying. This is one that hopefully, again, the community appreciates it, but this software team will be very happy when we don't have to support all the legacy pieces and the new features that we're trying to deliver out. The origins have gotten a lot closer to batteries included. My ultimate goal is if you can run a Wi-Fi router, you can run an origin. So this means that we now have a web user interface to view what the heck this thing's doing. You can actually configure the software through a web interface if you're slightly allergic to the command line. It has built-in health checks, and it can even do connection reversing. So we're working to make sure that you don't even need a open TCP port, a host name, a certificate, all this stuff long term is going to go away. And if you just drop this service inside your lab with no incoming network connectivity, we should be able to connect you to the OSDF. And then finally, we've been working a lot on new backends. So since the start of the project, we've delivered a S3 backend. So we can now plug into any S3 compatible endpoint. We can plug into any generic HTTP server. So if you just drop an Apache server on the web and say, hey, Brian, go call your team, your operations team, and connect this to the OSDF, we can do that. We are working on the Globus server, and this month's release has the very preliminary integration with Globus. So if your university has a Globus endpoint, we can, from outside, connect the two and expose a Globus collection into the OSDF. And then for those running the X3D protocol, we can even do that as well. Looking forward, again, this is a 4-year project. We're just getting cooking. We are wanting to do more backends. The Globus backend, again, this is just now released this month. We have a long way to go, and I think this is going to be one that, again, many people have asked for. It won't be maybe the most popular backend, but I suspect a lot of folks will ask about it. There's a lot more functionality, particularly around some of the, I guess I won't call them metadata operations, but your stats and checks on management, things like that. For those of you from the WLCG, the goal is that this will become integrated enough that you can use FTS to move data in and out of the Pelican origin. Dataverse is on our lists for next year. So this is a popular higher level kind of cataloging data repository software that many libraries use that we'd like to be able to eventually get to the point where you can give me a DOI and I can integrate within the OSDF and deliver that data. And quite a bit to do with origin monitoring and throttling. So some data sets, particularly around NASA, have really strict rate limits of what we can do, and being able to manage the request rate and load is going to be important for some of the next set of data sets we want to hit. We have quite a bit of work to do left on the dashboard and monitoring. Again, Ron mentioned it, but our goal is we want to show for anybody running the service to make sure you understand how it's used and how that institution is serving others, who it's helping, who it's impacting. And we'll show the CE dashboard in this workshop and look at that and say, next year, I'm hoping to see the same thing with the OSDF. We're going to see deeper Condor integration throughout the year. I'm going to skip over some of the technical details, but the short version is we want to make sure that these two animals look and smell like they came from the same team. And we don't want the boundaries of these to be clear. We want these to look like they're coming from a single piece of software and a single vision. And then finally, to leave on a bit of an ambiguous note, we're starting to think about what does it mean to have sets of objects. Now, you can call this a bucket. You can call this, here I call it a collection. But while objects are immutable and it's going to stay that way, we're starting to really think about what does it mean to have multiple objects. Does it, are they coming from the answer from a query? Are they defined? How do we do access control for here I call it, again, collections? And this is going to be one of the great things that we're going to have to start nailing down over the next year. So, end things up. We almost finished a whole year. It's been quite a whirlwind. We've re-engineered a number of our services, and I think Frank's going to show you that we actually seeing a lot increased usage of the OSDF. We've picked up some great new science partners in CAR and supported some existing ones that were doing great science, such as NRAO. We're going to hope provide those running it with more visibility into the system and understanding of what it's doing. And ultimately, the project's a happy member of the HTC community and plans to be here for many a year. All right. Do you have any questions?